Hi, it's Phil, Arizona Rock Mineral, and I'm going to show you how my coal car unloader works. We have two types. With the setup, you'll get both. The best one I have, we call it the Gizmo. It's very, very intensive parts and labor, and I didn't know if I should make any more of these or not, but I decided, yeah, that's a good design. We're going to include this in your setup. Then we have the quick unloader, which is good for a small town industry. So I'm going to show you the pieces and parts here now. You have this device here that will open the car doors. The car has a center pin, and the center pin gets trapped between these two pawls, guitar railed here. Now the car is trapped, it can't move because the pawls are up. Then we have this linkage here that actually opens the car doors. The car will jiggle just a little bit, which helps get up. And this is operated through a pull ring or cable. Now how it's made, we have a couple of twin coil switch machines here that actually pulse. Here's this. And this here is very invisible. It can rock back and forth as a pip here. Take them. Now it held me back making more of these. I had to take 16 steel shafts and weld them to washers, fender washers. And that becomes part of my main linkage for the whole setup. One goes counterclockwise, one goes clockwise. And there's an example here of a link pin that goes next to two shafts together. Synchronize them. And we have a return spring to return the linkage back. When not in use, the pulse go down, switch machines. And I use the NJ switch machines. They're the latest models. They haven't been built for 2-3 decades, but I found a bunch on the internet and I went through and rebuilt and look good. I used to use Rix machines, but these have more features. You can actually you have contacts here where you could hook up red and green lights for your train crew to tell the engineer when to cut the power of the engine. When the ball goes up, contacts close, the red light could come on. When you're ready to proceed, you release the pulse and the green light comes on and the engineer moves the train to the next car. Well, also, it's all pre-wired. Use these terminal strips. All connections are soldered to wires. One of the wires here goes to your 16-volt AC, and on your control panel for your push buttons to move the pawls up and down. We also have a lead here that goes to the other side of the 16-volt AC to power the switch machines. In the center here we have a place where you could have your pull string come through to open the car doors. Now to make these parts, I decided to use 32 thousandths brass. It's very sturdy and won't allow any movement when operating the device. This is my master, and it's all got these holes here that are spotted for making more pieces. There's holes here for Rix machines or the KTM machines, it don't matter. And the bending device for the end plates, we have a plate on each end, the end plates, that are made in a tool with the same kind of 32 thousandths material. Put the material in here, drop it on in until it hits these stop heads, put it in. Now we can saw out the area for the bead, and also there's here for drilling and bending the ends to form the end plates. Now there's another piece that we call the center support. That's what holds the pawls in place. Center support. There's two of these made. They're also made in the same bending right here to keep all the parts consistent. And all is held together with small stainless steel 440 screws, or these are 256 screws, yeah. Now we make an extension here on it so there's room for the bell crank to work. The bell crank changes motion side to side to aft, which is lock assembly firmly mounted to the end of the device so it can operate. When you mount it out, you want your first riser like this. You can put a little bit of hold it so there's no motion in it. Then your sub goes under the flange right here, and there's two holes for 4 lace to hold lace. Now I use stainless steel wire for all my stuff. I stopped using brass wire years ago, but many times it breaks. It's still not big, and it lasts forever. And the little link wire here is like, oh, I don't know, 6,000-7,000 stainless steel wire, and I fastened it to some tubing to secure good, and it will operate your bell crank. Now the other device I have, what we call a quick unloader. It starts off with a more economical device here. See the pins that would come up and open your car doors? It's a very simple design. It does the same thing, except there's no pause. You have to spot the car yourself for unloading. So I made this thing ready to go. Even put a piece of Atlas carload bridge beams up there to hide it and make it look more like a real bridge deck. Now this operates a little differently. You have a cable in the back, comes through in the back, through guide tubes, and it operates levers for opening your car doors. And this is all put together for you, all retail, and all you gotta do is mount on your layout and get enough here for this to open your doors. Now the engine on your train, you leave your cars coupled to the engine because the engine is the brake that holds the cars in place. And I don't have a problem opening the doors because the engine will not drag or slip on the rails. It don't take that much effort to open the doors. You get this way, it's all ready to go. It's like that. Then we're going to move on to how the tipple works and how it's made. Okay, now we're going to move on to the cold tipple and how it's made and how it works. This is it right here. It's made of tinplate material, and the size was determined by what you could find at the hobby shop. Now you're lucky enough to find a hobby shop that's open or there anymore. And if there is one, they probably don't even have this stuff anymore because people don't scratch build anymore. The size of material I used was a 4-inch wide tinplate material, and they're all held together in the corners by brass angle, which you can't buy anymore. They don't make it. So I had to make my own from sheet brass and bend it. Now the secret behind this is we have doors that chutes that raise and lower. You want to be able to raise your chutes for your train going underneath so it don't hit the cupola or the caboose or any employees on the tops of cars. Now the chute doors are open with this lever, and it's spring loaded so that if you get screwed up and you're overloading coal, you just let go and it'll close for you. Another cool thing about the chutes is when you're loading, you sometimes move the car a little bit too far ahead so you can kick some coal forward a little bit. As the train is passing through, you're going to load the front of the car. It takes longer to load the front of the car. The coal falls towards the center of the car, and when it gets full, you slowly creep the train. We'll show you a video of it. When you get to the next car, you can hold chute up, the coal will stop, and the next car shoots the car. Like it as much as possible. And the meter that closes the doors is hidden inside this angle iron, well, angle brass. Now to stiffen up the brass, I use some brass rod stuck to the inside that makes it very rigid. It also allows me to thread the end of the rod so I can put a nut in there to hold firmly in place. Now underneath the tipple is we see all the mechanism. We use these bell cranks made from aluminum, and we use 32,000 stainless steel wire to control the mechanism in the tipple, and for controlling the bell crank we use 1/16" steel welding rod. It's all mounted to a bulletproof type of carbon plastic material, I don't know what it is, and the levers are made from aluminum, and I cut the slots in panel with a 1/8" milling bit to get nice smooth cuts, and there's no side plate and levers because it's a very close clearance, and it's all ready to go in your layout. Now I had to make tools for this. One thing is the doors are made of brass, and this is what you call a pocket for the doors. It keeps the coal from jamming in the front side of the doors, and keeps it all free so you can not jam your chute doors, which are made out of brass. Now the chute doors are just a piece of brass plate, and being that I use music wire, you can't solder music wire to brass, it don't work. So I take a piece of brass tubing that will solder to the brass plate. Now you bend over your music wire and put it inside the tube, and now you have a good secure way to control it, and it'll never break or come loose. The other thing I make is these chute supports. That's these little pieces right here. That's what the chutes pivot on, up or down. And there's special tools for making these. The chute supports are made with this tool jig I made here, which you can open up and slide your material in and make your chute doors. Anyway, the chutes themselves are made in this jig here too, so they're all the same. And I put my material in there and bend it over to form a chute, and after the material is cut off with I taper it. Now the chute pockets are made of this material. See how the opening is there for the chute? Well, it's made in this jig here, so you fold the metal over and make them all the same all the time. Now the template, so the tool here for making all those same. You slide your material up in here, the slide plates keep it tight, and it goes up against this stub pin right here. I clamp it in the vise, and I cut open the hole for the chutes. There's also a couple holes there cut to be slotted for the brackets that go over here to hold the linkage for raising and lowering the chutes. Now, there's a bottom plate to the material too. Here's another bending jig. I put my template material in here to the right side, and then there's a place to bend it over so it laps over the chute floor. And the side material, take the same template material. I think the sheets are 4 by 10, so when you cut a sheet in half, you get two sides are the same material, which is just a space-saving way of utilizing your material and not have any waste. And just putting a vise in the handle so you have something to solder to. Now it requires a lot of heat to solder this together. And inside I put a inside baffle so that when you fill it with coal, each bunker will hold enough to load 8 cars. 8 cars this side. And that determines how many cars we give you in the setup. So you get 16 cars, 16 operating cars. One side will load 8 cars, the other side will load the other 8 cars. That makes up a nice train. So I've decided I'm only going to make 5 of these cells. 5 units, Tipple, 2 unloaders, and 16, 5 sets. They'll never ever be made again.